Okay, yet another final review I've made about like a lot of these types of packets. 180 is not a perfect square, so it's time to divide into the 180. And you start dividing, you'd start at 169. Doesn't work. Then you go to 144. Doesn't work. Remember, you're dividing by the perfect squares. Nope. 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 Cha-ching. So I rewrite that as the square root of 36 and 5. So that becomes 6 whole, and then it's 6 whole square root 5. Okay, 16 is a perfect square. It's equal to 4 whole. 15, I don't think 15 divides by 9 or 4, so that means it's a prime square root, and really it can't be simplified. Now, don't use 1 and 15. You didn't do anything. Okay, now square roots with variables. So I have the square root of 45, and then I divide into my 45. So 36, no. 25, no. 16, oh, I could divide it by 9. So I rewrite it as 9, and its partner factor to get 45 is 5. So it's 3 whole, 5. Now remember our game plan here with the odds. We know if we have an odd, you're going to have an x that doesn't come out of the square root, and then you can take that down to 2. Now I take half of 2, which is 1, or you can just put x2. Okay, 6 is already, I can half that. That's going to be y to the third. I don't need y inside. Here I put z inside, and that allows me to take that to 10, and then z to the fifth. Okay, the multiplying operation, 3 steps. 5 times 2 is 10. And I take 5 times 15, which is 75. Okay, now remember you're not done at that point. You got to divide into the 75 and see if it's divisible. If you can get another whole number to multiply by that 10. So divide by 64 decimal, decimal, decimal. Cha-ching. Okay, so you got to remember to drop the 10. Okay, you're going to rewrite the square root of 75, but that 10's still there. So 25 and 3. So 25 becomes 5 whole, and then I could take 5 whole times 10 whole, and that would be 50 whole square root 3. Okay, now addition, again, to do the operation, these numbers have to match, and right now they don't, so I need to rewrite the problem after I simplify. So 5 square roots of 60, 4 whole square roots of 15. So I divide into the 60. So I don't think 60 divides by 49 or 36. Whoops. Or 25, or 16, or 9, whoops, 9, 60 divided by 9 is a decimal. Well, 4 doesn't work, we got a problem, but it does work. Okay, so I drop my 5 and rewrite that as the square root of 4 times the square root of 5. Okay, so the square root of 4 is 2 whole, and remember, you got to take the 2 whole times the 5 whole, which is 10 whole square root 5. So I rewrite that as 10 square root 5. Again, this and this are equivalent. This is simplified. That is not. Whoa, I did that wrong. 60 divided by 4 is not 5, it's 15. Okay, so it's 10 whole square root 15. Okay. Now, divide into the 15, okay? Divide by 9 is a decimal, divide by 4 is a decimal. So basically, I'm just going to leave that one alone. So 4 whole square root 15. But it doesn't really matter because I've accomplished what I need. I have the square roots as identical, and then I add 10 to 4, and that's 14. So 14 square root 15. Okay, solve for x and y. Okay, when you don't know two sides, you're going to have to use proportions. But it's a 30, 60, 90 triangle. Okay, so remember, the hypotenuse is proportional to 2. Across from 60 is proportional, but 60 is here, so remember, the square root of 3 is proportional to x, and then 1 is proportional to y. Okay, so again, what we're going to do, we knew we had side 15, so 15 over x, 15 over y. And then I put 15 with 2, and then x with the square root of 3. And then 15 again is with 2, y is with 1. Okay, now I take 15 times the square root of 3. All I can do is write 15 square root 3 with that, and then divide by 2. Now 15 divided by 2 is a decimal. That's okay, write it. You can get decimals. 7.5 square root 3 equals x. Then over here, you're going to take 15 times 1, which is 15, divided by 2, and that's 7.5. Okay, so 7.5 equals y. Okay, same thing here. So remember, this is 45, 45, 90, so the hypotenuse is proportional to the square root of 2, and then the 45, opposite the 45s are both proportional to just one whole. Okay, so I had side 9, so 9 over x, 9 over y, and then 9 is proportional to the square root of 2, x is proportional to 1. And then the same thing's going on over here, 2 and 1. So the answers are going to be exactly the same, okay? So 9 times 1 is 9, divided by the square root of 2. Now, again, you can't really divide by the square root of 2 a whole number by a square root. So what you do is put square root of 2 on top, and that enables you to get rid of the square root on bottom. And now you can divide 9 by 2. So that's 4.5 square root 2. That's your x. And I don't even need to waste time with the y because it's exactly the same. It's going to be 4.5 square root of 2 equals y. Because it's the same exact proportion. Okay. Yeah, it makes sense. Yeah, it's an isosceles triangle, and you got 9, so these two are going to be 4.5 square root of 2. Okay, find the 3 trig ratios of angle theta. Okay, so sine is opposite over hypotenuse, the cosine's the adjacent over the hypotenuse, and the tangent's the opposite over the adjacent. Okay, now the hypotenuse is always in the same place. It's opposite the right. It's the side across from the right angle. But O and A depends where the theta symbol's at, the angle. Okay, across from the angle is always the O, and then the A is the third side. So again, I know 2 sides, but not the third, so I use the Pythagorean theorem to find the one side I don't know. Because if I find that, I'll know all these so I can fill it in. So A is a to the second. O, I take 16 to the second. And the H, I take 25 to the second. Now get rid of these, simplify those second powers. Okay. You take 16 to the second power, or 16 times 16, it means the same thing. That's 256. And 25 to the second power is going to be 625. Okay, now your two values are on opposite sides. You're going to want to minus 256. Okay, so I take 625 minus 256, that's 369. But remember, that's a to the second. To find the actual a value, that means a times itself is 369. So we find the square root. It's probably irrational. Most of the time it is, okay? 19.21. Okay, so you got your adjacent side, 19.21. So O, 16, H, 25, A, 19.21, H is 25. Okay, O, 16, A, 19.21. Okay, then we got to find the 3 sides and the 3 angle measurements, okay? So they're right there for you, so let's do the sides first. Now, it's not a 30, 60, 90, okay? So you're going to need the OA and 8. You need to think of it in those terms in the sine, cosine, tangent, because it's not 30, 60, 90. It's not 45, 45, 90. You're going to need proportions, but they're different kinds than what you used on the previous one. So again, across from the hypotenuse is always the h, which I don't have the value for. So I use 33 degrees as my reference, and across from that is the O, and then A is 8. Well, I have A. I know that's 8. Now it's time to solve for the O and H. So I'm going to solve for the O here and the H here, but we need that A in each proportion because I know I can replace it with 8. So O and A is the tangent function. Remember, oh, sorry, you should put 1 and then your degrees. Okay, so 33 degrees. Then H and A is the cosine function. Okay, so that's OA, that's AH. Okay, so the A is 8. Okay, and you have to do OA, you have to do AH. It can't be the opposite. Okay, you can clearly see that that's what those operations are equal to. Okay, so I cross multiply and divide. So the O is diagonal from 1. Okay, here the H is diagonal from cos 33. Okay, now here I have to multiply then the other two. So I take tan 33 times 8, and I get 5.20. And that's your O, okay, 5.20. Now the H better be longer than 8. Well, 1 times 8 is 8, so I'm dividing 8 by cosine 33. Okay, 9.54 makes sense. My H is always the longest. Okay, so in degrees you got 90, you got 33, and I take 180 minus 90 minus 33. Okay, 57. Okay, now I'm sorry about the stupid writing. I had to copy paste. They ain't easy to find 12-sided regular polygons, so I got this thing on a website, and I had to copy paste. There was no way to delete that, so I apologize for that. Okay, I don't even know how to pronounce a 12-sided polygon. Okay, but I darn sure know how to find the area. S times N times A divided by 2. So the side length's 5. The number of sides we have is 12. Now there's the apothem. Now I'm sorry, but the apothem, just put it here. Right angle. And that's your A. Now again, I make that into a right triangle. Now I know to find the A, I'm going to have to use my proportions using AOA. AOH, sorry, but although I don't really need H. Okay, now first off, we have an odd numbered side, so I divide that in half, and it's 2.5, so we're going to put 2.5 right there. Okay, now I need some degrees to go here, because you have to have a degree measurement in the center angle. So you take 360 divided by 12 divided by 2. That'll tell you how many degrees you have in that right triangle you just made. Again, just dividing it by 12 is a centered triangle, but I made a right triangle, so then I would cut that in half again. 15 degrees, okay, and you can see it's 15 because that's a small angle, okay, so there's my thing. And again, I want to find the A, and I know the O is 2.5, okay, so that's why it's always AO, and that's always tangent. And that's O on top, A on bottom. So I have the O. O is 2.5. And I'm finding the A. That's my apothem. It's also the adjacent side of the right triangle. So it kind of works cool that that's both A. Okay. So A is diagonal from tan 15, which we got to put in the denominator because we can't multiply that way. But 1 times 2.5 is 2.5. So I take 2.5 divided by tan 15, and I get 9.33 as my apothem. And I multiply those, and that's all she wrote. 5 times 12 times 9.33 divided by 2. 279.9 square feet are in that dodecagon or something. I don't know how to pronounce it.